Hi everyone, in this video I will continue discussion on the mesh module just in case if you haven't watched the video series that I have recorded on the given options that are present in STKO, then I'll recommend you to watch those videos before watching this video because it will be very important for you to understand this and get the idea of working on STKO for OpenSees. So now I am at global seed. I'm at mesh option here, and I have some options related to seeding, some options related to controls, and some options related to belt here. So I won't spend any further time. Just I want to explain the options here with what is the global seed doing here. So the global seed is basically define the global definition for the seeds that I want to consider in my model before meshing the model here. So it is kind of a domain for selecting criteria for the mesh here. So currently I have this option here and I discussed this previously in this frame. So if I go to the global seeds, I have some options that are available here. Currently, it is based on division. So if I try to do this in one division, at every corner it will assign the same dimension as a single element here. And it will be based on the units. But if I change this to various numbers, it will be changed here. Other than that, I have this option for the uniform size, uniform by size, uniform by divisions, biased by size, biased by division, dual biased by size, dual biased by division here. So these are some options that are available here. So let's demonstrate further by just clicking on assign. So the STKO is giving me an option that it is generated here. So for uniform by size, for example, if I assign a size of 1 and assign it here, so 1 is a very smaller unit and it is divided into 1 because we consider 100 units this side, 100 units this side, and 100 units this side. So if I make it 100 and it will make it a single element for each size. So this is uniform by size. If I make it 20, 50, one point here, one here, and one here for the global seed will appear here. So for example, if I make it 50, it will assign automatically. Other than that, if I assign 80 or any other value, so STKO will look into the domain here. If it is able to divide that and the overall length of the member, then it will divide it. And if it is not able to divide it to the overall length of the region, then it will not able to divide it. For example, if I select 80, which is greater than 50 and less than 100, so it means it's not able to identify that region here. But if I make it like this, for example, if I make it 40, then it will divide this into smaller units, right? And this how it works. If I switch it back to 50, it means single unit will be assigned. If I make it 10, then 10 divisions on each side will be generated here. So you can see here and you can count them here as well. So this is related to uniform by size, that it will look into the each member and divide it in a uniform size other than just jumping into a biased conclusion here. After that, we have uniform by division. So if you want one division, it means that each member will be divided into one division. If we want two divisions, so it will look into each corner and all these members that we have defined here, and it will divide it into two members here. For example, if we consider three, it will divide it into three, and if we consider 10, it will divide it into 10. Uh, the global seeding ratio with uniform by division is not recommended because sometimes we have a smaller and larger smaller and larger element. So in that case, it will not look into the aspect ratio. It will just divide those members. So there will be a no consistency concept in the or STKO environment for the meshing division. Anyways, let's switch to bias by size. And now with this bias option that is available here in um, STKO, we must make sure that if we are using this option, this bias will look at the way we constructed the model. It will look into the model and it will start dividing it from the starting to ending point. If we have model this using clockwise notation, so it will search for the clockwise notation bias size, and if we have model it with anti-clockwise rotation, then it will consider an anti-clockwise rotation. So let's look at here. For example, I consider the size of 10, and I consider size of 100, and I consider 1. So we can see here it's just starting dividing this in one direction. But now look at here that if you remember in the previous video, I modeled this using a clockwise notation. So that's why it is considering it a clockwise notation. So for the bias, it will start from the smaller unit and it will go to the larger unit here. So for example, if I make it 50 and if I assign it here, it's not changing it yet because it is a biased by size approach here. So, but if I make it 100 and if I make it biased by 25, you can see here that that ratio of changing is occurring here. So if I make it 5 and assign it here, so we are getting those ratios here. And if I make it 100 and assign it, you can see still we have those options here. If I make it 1, we will get a very final ratio here. It will start from 1 in the ratio in the size, and for the bias of 5 at the end, it will make it 5, and a gradual definition of the mesh will be assigned here. So in that case, if you want to reverse the direction, you can reverse the direction, but make sure that this drafting is done in such a manner that node number first is drafted first, then second, then third, then fourth, and similarly, member A, B, B, C, and C, D are connected in that pattern here. So that's why this notation that we are using here is following that standard approach here. After that, bias by division is another option. So if you want to do that by division, so if you want 10 division with the size of 5 bias, and we assign it here, so it will divide that whole member into 10 portion, and for the smaller portion, it will assign 5, and then it will adding that 5 gradually in the aspect of ratio and doing that. And the reverse work in the same way here. After that, if we want to do division with double bias here. So for example, with 5, I want to make it, for 2, and the in bias, I want to make it 5, and I want the center to be in the starting direction. So I can see here that it is in this way. If I change it, it will not that much affect the results. If I want to change it in this way, I can do it here. For the end of the bias, if I change it to 2, I will notice that from the center it will go to this direction as well as it will go to this direction. If I make it 0, I will still not be able to get any difference here because the ratio is selected in such a manner that we are not able to understand the nature of the element to STK over here. So if I make it 5, I can see their bias direction is in that way by division size. If we make it dual biased, then we can look at the region here. That with dual bias, it's considering that direction, and if we change it, we will still not able to feel the difference here. So it's not a big deal to be worried about. For example, if I want to make it 5, it still have the potential to consider it here. So the best practice is always if you are interested in a specific region in your model. For example, if you are doing it with the single biased, right, and assign it here, if you want to make it division, so always be um, logical about modeling this. For example, if you drafted one member using clockwise direction and another member using anti-clockwise direction. So if your consideration is a specific node, for example, in this way, if we consider node B here, which is actually this node, and if we are studying the local behavior of this node in the analysis based on the global response of the structure, then we should draw this member in anti-clockwise direction and this member is clockwise direction. So in that case, if we assign that bias, so we will be able to get a best meshing approach here. Anyways, whatever it is, we did this and we have this mesh here. If we consider the edge sheets, so if we assign this and we make it as another approach here, for example, uh, that one was global one, this is the edge sheet. For example, for node B, if I want to select this one, right, and I want to make it biased by division, reverse direction, make it 10, make it uh, 5 and assign it here, I'll make it 2 and assign it, sorry, 5, assign it and make it 100. I'm sorry, make it 1 and make it 1 as well. So we still are able to control this using the control direction, but anyways, um, we are not getting that by bias by size. So bias by division is a good approach here. And if we make 100 division, we will be still getting the same nature of the element here. And if I click on assign done, and if I select edge sheets here and I select this one and make it biased by division and 100, make it 2 and assign, sorry, 5 and select it again and assign it, still too much, let's make it 50 and select it again and assign it, which is too much. So division 25 will be good to visualize here. Okay, 25 divisions are still too much. Let's make them 15 and select it and assign it here. In a similar way, if we select this and assign it here in reverse direction and assign it back here. So now I got what I was looking for, and for this one I will select the uniform by size and make it 10 and assign it here. So now at this point I have basically the opportunity to study this node in a very detailed way as compared to the other options that are available here. Anyways, when we do this, we can then select any member to remove the mesh from it. And for mesh controls, we can do edges by changing them to based on the algorithm. If you are doing topology, then that's also okay. If you are considering the order, then that's also okay. For example, at this point, we have this linear approach here, and we have if we have faces at this point, we don't have any faces. I'll try to do a discussion using 3D geometry in the mesh analysis, mesh controls here. So we have all these options for the topology for tetra and hexa and unstructured and structured mesh. So this is the mesh control criteria, and I'll try to discuss this in a detailed way in the next video series in the continuation, just in case to make it more simple and easier for users to consider. So up to this point, the mesh is considered, and for the analysis, I don't want to consider this analysis in this point because currently I have no reliable file available with me which I can run without the fear of non-confidential results. So that's why I will try to make a file that is easier for me to use, and then I will continue discussion on the analysis and then the post-processing module. But it's not difficult to consider. It's very easy to just assume these directions and practice the STKO software. So my next target is to study the properties and the definitions to make it more easier in terms of OpenSees. So this will be kind of a technical discussion, and I will be making topic-wise discussion on it using Python to make it more sensible and more easier to follow here. Right, so we have then limited curve and miscellaneous and all these options. So there will be a detailed discussion on this definition criteria in STKO. So stay tuned because this will give you an opportunity to understand OpenSeas documentations as well, along with STKO. So if you have capability of using these uh, three options that I mentioned previously, as with the element property, the physical property, and the definition, that you are professional on STKO and the using of STKO, then all you need is to just consider practicing STKO with OpenSeas, and you will be able to understand various aspects in your model. If you have any problem, I have provided my WhatsApp number on the description of the video, so you can connect with me on WhatsApp and ask me about OpenSeas as well. And I'll appreciate if you have any questions, then you can put them in on the video on my YouTube channel. So this will be a more easier way, because if any other guy experience that problem, so he will be able to get, or she will be able to get the answer to the questions they are asking for it. Anyways, thank you so much for watching. Have a good day.